Hi everyone, in this video I'm going to be discussing the concept of percent error, or how far off your experimentally determined values are from what's accepted as true. I just went on to reference table T because I know that this is a calculation that I'm going to have to do, and I found this equation listed under percent error. The idea that a measurement of percent error just takes a value that you've measured experimentally. So a measured value will always be some sort of experimental data, and I'm going to compare that experimental data to some accepted value. An accepted value might be given to you as true, or it might be listed in your reference table. But what that accepted value means is that it's been something that the scientific community has over time grown to accept as what is quote unquote true. This times 100 at the end is an important component of this equation, as we'll see in our example, so don't leave it off if you're ever looking to set up a percent error calculation. I want to give you an example problem so we could work through the use of this particular equation. So in this particular problem that I've got for you in gray, the density of a sample of iron is measured as 8.01 grams per centimeter cubed. I want to know the percent error of this measurement of density. So I see automatically that I'm trying to calculate percent error, I'm trying to calculate percent error of a density measurement, and I'm given a particular measurement of density that was measured experimentally. There are two different ways that you might be asked to solve for percent error on the Regents exam. And the first is just to show a numerical setup. So if you see the phrase numerical setup, what it's really just looking for is, do you know what the measured values are, what the accepted values are, and how to plug them into that percent error equation. So let's go through step by step and see what we need to do. If I was just looking for a numerical setup, I'd always start by writing out my equation, because this eliminates silly mistakes of plugging in the right values in the wrong places. I know it's my measured minus my accepted over my accepted times 100. And looking at that problem, again, this 8.01 value was measured. It was given to us experimentally. So I know my measured value is equal to 8.01. But there are no other numbers in the problem, and I need an accepted value. Because this is the physical property of density that we're talking about, I know I can go to table S and find the accepted values of density listed for near every element on the periodic table. If I come down to iron, I see that its accepted value of density is 7.87 grams per cubic centimeter. So my accepted value comes from reference table S, and it's 7.87. So a reminder, this is from reference table S. From here on out, it's just plug in. For a numerical setup, all I need to show is that I know if into my calculator I typed my measured value of 8.01 and subtracted it from 7.87, divided it by the accepted value of 7.87, and multiplied by 100, don't forget that ending piece, it's easy to want to skip over, I would get to a correct number. The reason you need to include this times 100 is that a numerical setup should be able to be entered into a calculator in its written form and get to a correct answer. If you leave that times 100 off, you're going to be off by a factor of 100, so don't forget this ending piece. You may actually be asked to solve this whole equation, and that's not a big deal because you've got your calculators with you and you've got your ideas of orders of operation. All we need to do is get this into an actual number. So if I'm actually going through and working the calculation, I'm going to do this one step at a time. You can, of course, use parentheses in your calculator. I'm just going to do it step by step and look to see that 8.01 minus 7.87 is a value of 0.14. I can divide that number by 7.87 and then multiply that times 100 to get my final result. I get 1.78. I'm going to round to the nearest 100th percent error. Now notice that this was a positive value because my measured value was higher than what was accepted. If there's an instance in which your measured value is lower than the accepted value, you're going to come out with a negative number, and that's okay. In my class, a negative percent error just means that you are below what was accepted. If you ever see a negative value on the Regents exam, though, sometimes in a multiple choice question, they may actually take the absolute value of this difference so that all answers turn out positive. Again, in my class, it's okay if you come up with a negative answer. That's perfectly fine and perfectly acceptable. On the Regents exam, again, if it's a free response calculation, I think that's okay. If it's multiple choice, you may see an absolute value of a number rather than its sign included.